This video is about the basics of learning and memory, which are fundamental processes in the brain. We'll explore how we acquire, process, store, and retrieve information on this journey through the brain's functions. We begin with learning theories. Behaviorism focuses on learning through rewards and consequences, where positive results lead to repetition. Cognitivism views the brain like a computer, focusing on how we process, store, and retrieve information through memory and chunking. Constructivism suggests we build knowledge by connecting new information to what we already know, making it an active process. Social learning involves observing and imitating others, while experiential learning is about doing, reflecting, and trying a better way next time. Learning methods include spaced repetition, which involves studying over multiple days, and active recall, which is testing yourself. The Feynman technique involves explaining a concept simply, and dual coding combines words with visuals to store information in two different ways. Kolb's experiential learning cycle illustrates how learning is a process that moves through four stages: concrete experience, reflective observation, abstract conceptualization, and active experimentation. The cycle starts with concrete experience, or doing, where you perform an action. Then comes reflective observation, or reviewing, where you step back to see what worked and what didn't. For example, trying to bake a cake and realizing it failed. Next is abstract conceptualization, or concluding, where you make sense of your observations and form a theory. Finally, active experimentation, or planning, involves taking your new theory and planning how to test it out in a new situation. Learning styles can be categorized by sense. Visual learners use images and diagrams, processing them very quickly. Auditory learners prefer listening, such as to lectures or podcasts, and often need to talk things out. Kinesthetic learning is learning by doing, including muscle memory, such as playing an instrument. Verbal learning, a subtype of visual learning, focuses on the written word, like taking notes and reading manuals. Other senses are involved in learning too. Olfactory, or smell, is strongly linked to memory. Gustatory, or taste, is vital in culinary arts and chemistry for direct feedback. Proprioception is your sense of space, which athletes and dancers rely on entirely. Multimodal learning works for three main reasons. Redundancy ensures that if one memory cue is forgotten, another sense can recall it. Neural pathways are strengthened by using multiple senses. Lastly, engagement is increased, making it harder for the brain to zone out. Sources for sensory learning include visual tools like YouTube and infographics, and auditory sources like podcasts and audiobooks. Kinesthetic learning is supported by DIY kits, sports, and labs. Multimodal learning sources include interactive apps and virtual reality. The multi-store model of memory, or the Atkinson-Shiffrin model, suggests information moves through three stages. Sensory memory captures everything briefly. Short-term memory has a limited capacity and lasts about 30 seconds. Long-term memory is where information is permanently encoded. This flowchart visually represents the multi-store model. Information flows from sensory memory to short-term memory with attention, and then to long-term memory through rehearsal. Or it is lost to forgetting. The working memory model, by Baddeley and Hitch, sees short-term memory as an active workbench composed of different processors: the phonological loop for auditory info, the visuospatial sketchpad for visual info, and the central executive, which directs focus. The working memory diagram illustrates the central executive focusing, planning, and controlling, the phonological loop for verbal and auditory input, and the visuospatial sketchpad for visual and spatial input. The episodic buffer integrates this information. The Levels of Processing Theory by Craik and Lockhart suggests how you think about something determines how well you remember it. Memory is a byproduct of analysis. Shallow processing, like noticing physical traits, leads to weak memories. Deep processing, or semantic processing, involves thinking about meaning and relating it to yourself, creating strong, lasting memories. Schema theory explains how we organize knowledge using a schema, which is a mental framework built from past experiences. It acts as a shortcut. When we go to a new restaurant, our restaurant schema helps us know how to act. While schemas aid memory, they can also cause us to, quote, fill in the gaps with false memories based on what we expect. Dual coding theory by Paivio suggests we remember things best when stored as both a verbal code, words, and an imaged code, visuals. Two paths to the same memory double the chance of retrieval. To effectively train your memory, you must first know which memory system you are targeting. This table outlines the three types of memory, what they handle, and an example for each. Sensory memory holds immediate snapshots, lasting about 1 second, like the feeling of the chair you're sitting on. Short-term or working memory is for information you are currently using, such as keeping a verification code in your head. Long-term memory is for information encoded permanently, like remembering your mother's name or the alphabet. It is unlimited in capacity and duration. Long-term memory is further categorized into implicit and explicit memory. Implicit memory is unconscious, like knowing how to tie your shoes, and is motor-based. Explicit memory is conscious memory of facts and events. It includes semantic memory for general knowledge and facts, and episodic memory for personal experiences and events. Training working memory can be done through dual n-back, digit span, and visual spatial exercises to improve focus and processing speed. One approach to training memory is creating an app with various cognitive tasks. This is a code sample for a menu to switch between tasks like digit span, spatial path, and one-back. The sample application can include exercises like reverse digit, where you recall numbers backward, and color sequence matching, both of which target different aspects of working memory. Thank you for watching this video on learning and memory. Stay tuned for the next section, where we will explore deeper concepts and the theories of Freud and Jung.